Okay, hello. I am working on Slinky today in an attempt to test out my live streaming setup. So, Slinky is my library for for creating React apps using Scala. And so recently, Facebook released something called React hooks, which is this super cool new way to write applications. So normally when you're writing a component in React, it looks something like, let's see, what's a good example? Component test. So you'll write something like this, right? Where you'll have a component, you'll define the props in a state, and then you define an initial state, and then you can update your state inside and stuff like that. Now, the issue with this is you end up with a lot of boilerplate. Like you have to extend definition, you have to define a state type if you're in a type-safe language, and then you have to call this set state method everywhere. So what hooks lets you do is clean all of this with a concept called functional components. So functional components are components where all you have is a single function which takes in your props and returns your value. So normally this is only useful for stateless components. So you have your props and you're going to return some HTML element to render to the screen. So this is kind of what it would look like. Like if I have a functional component which takes in an int and I convert it to a string, then if I use this component and pass in 1 as the props, then the HTML generated will just be 1. So that's kind of what functional components started out as, but React recently announced this new hooks thing, where basically now you can do something like this, where you say, okay, I'm inside this functional component, and this functional component will use state. The default state value will be hello, and that gives me two things back. It gives me the current state and a function to set the state. And so the really cool thing with this is now you don't have to specify your state ahead of time. You can just specify it in here. And in addition, you can take like the state value and just use it as if it's a regular value. So you don't have that separation of, oh, I need to have a render method and then I need to define state separately. Now everything's in one place. And so that makes things really nice. So what I'm working on today is adding support for these hooks to Slinky. So right now so this is the code that goes into actually making this available in Slinky. So we have this add.js import, which is basically loading up React. And so this definition of use state is what's called a facade. So this defines the input type, the output type. And so if you want to call this, you would have to convert everything to the appropriate JavaScript types. But for users, we want this to be available as like a very nice type. So this hooks public object is what's actually going to have the APIs that regular users are going to call. Now, the issue that I'm working on right now is hooks has this. Let me try pulling in this API. Okay, cool. So hopefully you can see that here. Okay, so if I pull this just separately, let me maybe shrink this a little bit. So one thing you can do, so normally you can just do set state as use state. Usually you just call set state and a new state value. But sometimes you want to just transform the current state. And so that has this thing called functional updates. So you would take the set state, but instead of just passing in a new value, you would pass in a function, which takes the old value, so pref count, and then returns the new value for the state. Now expressing this in a type-safe language is a little bit messy because now you have to have some type of union type because you could either take a value or a function that's going to return that value. And so what I'm working on right now is this hook callback thing. So I'm going to actually just replace this with a final class. And this is going to wrap around the actual function inside, and it'll expose multiple methods to either pass in just a new value or pass in a transformer value. So this is going to be an any-val. And we'll take some private val orig function, which is going to be a js dot function. Let me zoom in. Function 1 from our type. Let's just call this js.any to unit. So unit is the equivalent of void if you've done stuff in Java before, you'll know that if you have a function that's not going to return anything, you just return void. Here we return unit. And because we're going to be either taking in a value or a function that returns a value, I'm doing js.me, so we can just basically pass in anything. Now we have two functions. I will just replace this as question for now. So we're either going to take a new state or a transform state, which is going to take t to t. And this is a cool thing you can do in Scala. So if you are defining some type of API, but you don't know exactly what it's going to look like yet, you can just put question, and at runtime, this code will actually compile, but at runtime it'll just crash. But that lets you fill in the blanks, and the compiler will warn you if it detects that you still have questions left that you haven't filled in. Cool. So now we have use state, which is, we still have two use states. So the kind of funky thing with use state is you have two potential input types and two potential kind of output types, or ways you can use the output. So the input types is either you can have a default value, which is just the value, or you can have this lazy default value, which is this lazy initial state. And so the lazy initial state lets you, instead of just passing in a value, pass in a function. And the reason for this is, with hooks, this is actually just a function. So that means on every single update of your component, it's going to call this function again. But if calculating your initial state takes time, then this is going to be a problem, because you are going to recompute that expensive value every time, even though you only need to calculate that initial state once, which is when the component mounts onto the screen. So that's why we have this lazy option. And now I'm going to replace this with set state hook callback t, and set state hook callback t. And what I'm going to do now is my _2 value. What is the type of _2? Type mismatch found required. Okay. We're going to return set state hook callback of t with this. And so now we are passing back this hook callback. Now this is not compiling. One cool thing, this is VS Code, but I'm actually able to get errors here because of a really cool extension called Metals. It's the Scala meta language server. So this actually in the background is just running the regular Scala compiler, and whenever it gets errors, it dumps them back onto the screen. So we can see those. Okay, so right now we have a function. Let's see. Okay, what does use state return in hooks raw? Okay, let's just have this return js.function1 from js.any. That should make this happy. Yes, okay. And let's use this here. So now we kind of duck type that. Okay, cool. So first, let's make sure that everything still compiles here. Let me open up an integrated terminal. Okay, so let me keep SVT running in the background so we can start running the unit test. So here right now, I just have a couple of simple unit tests. So here, wait, this is just duplicated right now. So let me drop this for now. So this is just, okay, we can render the functional component. We can call use state. This isn't testing the behavior of set state yet though. So we'll check that in a bit. Okay, so now we have this set state hook callback. Either we're going to get just a direct new state. So if we get just a new state, we're just going to call orig function dot apply new state, and we have to cast it because it's expecting a JavaScript type, but here we're just getting some random object. And in the other version, then we want a JavaScript function. So we're going to do something :js.function1 of t to t, and this is actually just going to be transform state. So we're just going to take transform state. There's an implicit conversion, so that handles automatically converting everything between the types we expect. And so now we get back transform state is a JS function from t to t. All right, okay, that looks good. Let's run our unit test. This might take a while, but in the meantime, we can probably start writing another test. I can call set state on. So what I'm going to do for this test is we'll make this an async fun suite so that we can do asynchronous tests. Because set state is asynchronous, so we need to, well, what we're going to do is we'll call set state, and then we'll have the component report back to us when the state has actually been updated, when we detect that that's been updated. So we'll know that, okay, you can call set state, and that triggers a component to be re-rendered with the new state. Okay, so now what I'm going to do is I'll create a var state setter, which is going to be a set state hook callback. String is going to be null for now. And then, okay, we need to import this from the facade. Okay. Why does it not like this? Null should be fine. Set state hook callback. Okay. I'll just cast it now. Okay, what's the error? Oh, not found. Okay, that should be fixed then by now. Okay, let's see what happens if we recompile. I think this might have an issue with it being an anyval. So we will have to see about that. Yeah, so because it's an anyval, we run into a problem because this hook callback, you can't just use null as an actual value for it. So what we can do instead, let's just use this as an option. So this lets us store this, and we may or may not have a value. And then what we can do inside here is, okay, we got our set state, so let's set our state setter to be some our set state function. Okay. Now what we're going to do is, because this is an asynchronous test, what we can do is use promises. So promises lets you say, okay, something is going to happen eventually. This is the thing that's going to track what's happening. And then within our functional component, we can just call when we detect that the state has been updated to say, okay, here's the test is completed. So state set promise is going to be a promise of, let's see, I did similar things in my component test. Let's take a look what I did there. Lots of unit tests. Okay. Yeah, promise of assertion. Let's do that. And we'll probably have to import promises. Yep. So that is just part of the Scala standard library. And assertion probably comes from Scala test. One feature that's not yet available, unfortunately, in Metals is code completion. So that means I'm kind of running blind. You can jump to definitions of types, but if you're looking for like assertion, for example, it won't tell you where to get that or complete those imports. But that's coming soon, so yay. So let's do this. Once we set our state, once we get our state setter, so we render, and then we'll do state setter dot get dot apply, and let's give it a new state of by. And then what we'll do here is if state equals by, so when we detect that the state is by, then we'll just complete the promise. And here we'll just return the promise as future. Okay, that should compile. Okay, so all together what we're doing is we're creating a promise. We're saying, okay, when we detect that the state is by, we mark this test as complete by asserting true. And so when that finishes, then the unit test will finish because we're waiting on that to happen here at the bottom. So let's try this. For some reason, it's recompiling a bunch of other stuff. Whatever. Okay, cool. So now what it's going to do, because React and everything is distributed through NPM, it's going to pull together all the NPM modules, and it's going to use Webpack, which is a build tool for web applications, to bundle everything together into one big JavaScript file, and then that's going to include all the unit testing infrastructure, and then it's just going to run that in Node.js. We also use JSDOM here because there are DOM dependent tests to test that. Like we can actually generate HTML. And so JSDOM emulates that behavior. Okay, cool. All tests passed. That is awesome. Okay, just to make sure that this is actually happening, I like to break my unit tests because it's very easy, especially with asynchronous tests, to put in assert, but that assert isn't ever getting called. And so nothing ever fails. And so the test appears to pass, but you're actually just not testing anything at all. Okay, cool. The test failed. Okay, so that means our test is not bogus. Cool. Set state with direct value. The reason I'm doing this is the next one is going to be with transformed value. Okay, so now if we want to, instead of just directly giving it a new value, if we want to transform the value, let's say we want to take this state and set it to the reverse of what it was before. And so that means it's going to be OLL. So that's going to be the new state after we reversed it. And so this is a cool pattern because it lets you not have to worry about the asynchronous part about all of this state management and say, okay, when you're going to be updating the state, just take what the current value is and pass it through this function. So you don't have to worry about depending on old state data or anything like that. Okay, cool, that works too. So I think with that, we are done with state. Let's check it out. Okay. Lazy state, set state. It's not automatically merged. That's nice. It helps us a little bit. Basic hooks, use state, return the stateful value. Okay. Okay, cool. So I think we covered set state. Now let's do the next one. Use effect. So this use effect is designed to help basically kind of replace things like component did mount or component did update. And so it runs whenever after the component has actually been rendered. So let's see. Okay, let's see okay. Accepts a function that contains imperative. Okay, this should be relatively straightforward to just have a direct this out. We won't need any of this set state hook callback stuff for that. So def, what is it? Use effect. This doesn't have any type parameters because we're just taking an imperative block of code. So thunk is going to be to unit. It does nothing. Oh, well, this is our JS facade, so we should do JS function 0. So that means it takes no parameters and it's going to return unit. And this is going to not return us anything. And this is going to be js.native. Okay. And now here we want to expose this, so use effect. But here we want to use nice Scala types, so thunk, which is going to be nothing to unit. Returning unit is going to be hooks raw dot use effect thunk, and that should compile. Okay, that compiles. So now let's write a unit test for this. So first, let me take a look at this because I haven't actually used use effect before. I've played around with set state or use state, but not as much here. Okay. Timing. The function is fires after layout and paint during a deferred. This makes it suitable for like setting up subscriptions and event handlers. Okay. Yeah, there's also use layout effect, which is if you want to deal with the DOM. Okay. Oh, we're going to have to also implement this because use effect lets you specify that, oh, I only want to fire this effect if specific values change instead of just checking all the props. Okay. Okay, let's just write a relatively straightforward test just to say, okay, it should be called on render. Can use effect. Hello. Cool. I am also like in parallel to actually working on this, trying to figure out how this whole Facebook live streaming thing works. So let me know if things are broken or anything like that. So, this looks a little bit blurry, but I don't know. Facebook compression issues, I guess. Okay, so use effect hooked fires after render. Okay, so we have a promise, and what we're going to do is here, and so if we don't need any state, we're just going to do use effect. We're already importing hooks to underscore. Okay, that's good. So we're going to do use effect, which is going to take a function from nothing to, and then what we're going to do in here is we'll just promise.success assert true. So this, what we're really testing is that this function is fired. And so we don't need state anymore. We don't really care about props. We don't care about this. All we care about is at some point this function is actually called. And we don't need this anymore either in here. Okay, so I don't know why it's installing GSDOM again, because we just ran unit tests. It's sufficiently fast, so I guess it works. Okay, cool. So it's bundling, so it should run the unit test in a couple seconds. And we'll see if our use effect works. This is like not quite test-driven development, but I guess it's close enough. Okay, that failed. Interesting. Okay, Q is empty while future is not. Oh, I think we're supposed to use a different execution context because what happens here is at the end of the test, it just checks have any of the promises even gotten set up, or are there any features that might have a chance of finishing? But here, because we're just rendering and this use effect is called asynchronously, this will finish, this will run immediately, and so this use effect might not have even come in yet. So what we're going to do is, let me take a look at my component test. Execution, search execution context. I'm pretty sure I did something like this somewhere else, maybe. Let's see. Anything fun, sweet? Huh. Let's search around to see where else might I do this. Implicit.global. Yeah, we're doing this in here, but okay, let me do a quick Google search. Scala test async execution context. All right, here we go. All right, reading Java docs is fun. Okay, execution. Here we go. Here we go. Let's do this. Okay. Let's go back to here, and now we're just going to override what execution context, and the execution context determines how these asynchronous blocks of code are actually going to be executed. So hopefully this will work. Otherwise, you might have to do some like wild true magic or something like that to make this actually function. Okay, cool. All tests pass. Yay. Okay, so that was all we needed. Again, because this is doing some weird async stuff, I just want to double check that I didn't, by mistake, just break everything. So let's do that quick. Yeah, this bundling process is kind of slow. I might, eventually just replace it to not bundle and just directly run it inside. Oh, what happened here? Oh no. Oh, okay. So the reason this is broken is, yeah, okay, this is fine. Because basically assert false immediately throws an exception and this won't capture that. And so everything just crashes. And so the future never gets completed. And so this test is just waiting for something to finish that's never going to finish. So I'm going to have to kill SVT. But okay, well, I guess that means our tests are working. So that's okay. All right, what is next? So I think I'm just going to go through the hooks and then go offline for a bit and work on some other homework. But let's try to see if we can get at least the core effects finished. Okay, so we need to support this version of use effect too. So let's do that. So it takes thunk and then a second parameter, which is watched objects, which is a js.array of anything. So now let's just copy paste this. But here we can do watch objects is just going to be a Scala sequence of anything. And here we can do watch objects.toJS array, which, and then we'll just cast underscore as, or we can just cast the whole thing as instance of js.array of js.any. It's a little sketchy, all the casting here, but basically we're just saying don't worry about it. It's a JavaScript type and everything's dynamically typed anyway, so we're fine as long as it's in the JS array format. So we do need the toJS array. We can't just cast because the representation of Scala sequence might be a vector or a list or something. But as long as we do convert it to a JS array, then we can cast it around and we should be fine. Okay, so now let's do a test that, what can we do? I guess if fires only when watched objects change. So let me check the docs for this. What is it? Okay. Default behavior is after every completer ever. This might be overkill and subscribe. Okay. To implement this, pass a second argument to use effect that is an array of values. Now will only be recreated when props.source changes. Okay. Oh, also we need to support this where you actually can return a function instead. So this will also need to change. Okay. So I guess first let's do this one. This one's probably a little easier to test. So let's use props for this. And what we'll do is we'll render the component in one, render the component with two. So we'll render it with one, render it with one again, and then render it with two. And so we can keep a count of how many times effect count equals 0. And so we expect, okay, this will increment our effect count by 1. This shouldn't because the props have not changed. And this should because the props have changed. So what we'll do is we'll just increment our effect count. And if our effect count is 2, then we're done. Yeah, this should work. I guess, let's see, what would be a better way to test this? Because this wouldn't actually handle the situation in which this also fires. Let's see. I guess what we can just say is first effect occurred is false. So we see, okay, because we want to ignore the first render, but we want to make sure that the second call to use effect happens when the props is 2. So we'll do first effect occurred is true. And if our first effect has occurred and we're calling this, we want to complete our promise, or with the assertion that our props are equal to 2. And it will not like this because it wants a try, so let's just wrap this in a try, and this will actually also handle the situation in which this fails. Not found value try, okay. Let's scala.util.try, I think. Yeah, okay. So now what we're just going to do is, by wrapping it in a try, this will catch the exception. And so that means that if this assert fails, it won't hang the test, but instead it'll just fail the test when the future completes. And so this should work. Let's try this, okay. Let's run the test. And then after this, let's implement the behavior to say, okay, when the component unmounts, make sure that the effect is also cleaned up. In the meantime, let me check if React DOM has render. Is there like a unrender? Yeah, unmount component at node. And clean up. Yeah, okay. That should help because in the next test, we're going to have to check behavior when we remove the component from the tree. And so in order to do that, we'll have to actually just forcibly unmount it. And so that will trigger the behavior that we're looking for with use effects return. Okay. Compiling is slow. Okay, now it's bundling. Hopefully that'll finish soon. I guess in the meantime, since it's already compiled, we can start working on the next thing. So first, let's just modify the end user API. So now it's not just going to be tunit, it's going to be either you can return another function or just unit. And here, same thing. This is going to be something to unit or just the unit. Okay, well, that worked. That's good. Okay, excellent. So the test passed. Now let's just make this work. So now use effect, what we're going to do is we'll have this will now be either, it's going to be a JS function, which is going to return, so the user passed in function either returns function 0 that returns unit, so takes nothing, returns unit, so that's what to call when you clean up, or just unit, so nothing. And so here now what we can do is, if our thunk is just unit, and the open close parentheses is the unit value, then we'll return unit. Otherwise, thunk dot as instance of nothing to unit. This is getting really messy. Let me pick this up over a couple lines. Else this, and this, we want this to be a js.function 0 of unit. Okay. Okay. Required function 0 or unit. Yeah, this is function 0 or unit. What are you talking about? Huh. When in doubt, cast, I guess. Required. Oh, okay, of course. So now we'll just return our thunk as an instance. Wait, what do we actually want to do here? We want to, yeah, okay. So this situation that it's the thunk, okay, so we're gonna pass in a function that's gonna take nothing, And then we're gonna call our thunk. Yeah, this is kind of ugly, but type safety, I guess. So this is gonna be a js.function 0 of, that's gonna return either js.function 0 of unit or just unit. And so we're gonna call it first. So that gives us the result. And then we're gonna, if our called is just unit, we're just gonna return called as ins or just unit. Otherwise, first let's make sure this unit compiles. Oh no. Type mismatch required JS function 0 of unit or unit. Required JS function 0 of unit or what in the world? Oh. Okay, let's just question this out. Oh, this is weird. Okay, let's just try finishing this. So we're going to take our called result. We're going to cast it to a JS, or we're going to cast it to first just something to unit because we know it's not unit, so it must be the function. And then this is going to turn into a JS function 0 of unit. Wow, this is really messy. Okay, yeah, this is not a surprise that it doesn't compile. Okay, so let's put parentheses around this so that we're converting that whole function. Okay, oh, okay, that was it. Yay, hooray. So what we were missing was we want to be converting this entire function to a JS function 0, not the return value. And so now, call the function. If it's unit, then we return unit. Otherwise, we take this, we convert it to the function that we know it is, and then, okay, awesome. So let's do the same thing here now. So instead of thunk, we're just going to copy paste this chunk of code. Yeah, awesome. No, we'll need the parentheses, and let's break this one up over a couple lines because we also have the watch object, which is a pretty long line. And called is going to be either, oh, called, what is the type of called? I think this needs to be in parentheses. Yeah, let's put this guy in parentheses too, just to keep things really clear. Okay, function to unit or unit. Okay, no, this is fine. This is a good error now. Because we're either going to have a function or unit, but Scala doesn't understand that this is a union type because union types aren't actually part of Scala. This is just a scala.js extra, but it's safe. We should be fine. Okay, so now let's write a unit test for this. So what we're going to do is take a use effect, and then what we'll do is we'll just return a function, which is going to do promise dot success assert true. So when this unmount thing is called, then we succeed. Okay, we don't need any of this. And now we're just going to render it and then react dom.unmount component at node container. Okay. Oh no. Oh no, oh no. Oh, okay, this is going to be a little messy. So the issue is the union types don't really work that well in Scala because they're kind of just hacked in through scala.js. So what we'll just do is use overloaded functions instead. So either we're just going to have a function that returns you unit, or if you have defined a function that will return function to unit, then we'll handle that. And that actually makes this a little simpler because here we know just unit. So here we can just do a very simple conversion. Where here we're just going to do func. And here, now here in this situation, we'll just do this. Yeah, okay. Okay, let's test this works without the watched objects, and then we'll copy paste this into the watched object version too. No, okay, it's not recompiling for some reason. Let's try. Okay, that for some reason it's just not compiling. Oh, core is not compiling. Oh, it doesn't like this. Let's just do this as unit. As an instance of that, because once we have a JS function, then we can cast it and we can be pretty safe. Okay, this really doesn't like it at all. Because this is so heavily dependent on implicit conversions, lots of things tend to break down here. Okay, why does it not like this? Oh. Okay, wow, this is one big error. And it's not even showing me the error. Hello? Okay, let's just see here. Okay. No, this is Cook's component test, whereas React double definition. Have same type after erasure. Oh no. Okay, so this is what I thought was gonna happen. So let's see, what is a good way to fix this? Yeah, we can just do some kind of magic. Equal, not equal, equal. I think we have that defined. Or we'll just copy this from shapeless. Shapeless type not equal. Yeah. So this is one way to handle this. So basically what we're going to do is we'll have to overload a use effect. We'll have them both take type parameters, and we'll have an implicit parameter which checks that the return type either is unit or isn't unit. And so if it is not unit, if it's a function to unit or not a function to unit. So if it's a function to unit, then we can just directly return that. Otherwise, we'll do the regular way of doing things, I guess. Yeah, should work, hopefully. What would be other ways to do it? Or I guess we could do something fancy and have a specific type for this. So maybe we can try that. So we can create a @js.native trait effect return callback return. And this is going to be a js.object. So this is a JavaScript type. And so now let's do effect callback return. So what we want to do is we want to handle two types of values. Either it's a function to unit or it's just a value. And to make this work a little better, because you might have situations where you're calling something at the end, but that doesn't return unit, but you just want to treat it as unit, we'll just have an implicit conversion from function. So implicit def from function. So if you have a function that returns something and you have a function which takes no parameters and returns something, then this is going to give you effect callback return. What we're going to just do is take your fn and convert it to a js.function 0 from that returns t and cast this. Then we'll have another one which is like from any, and we'll probably have to do this as like a low priority implicit so that it doesn't get picked up otherwise and we don't have things colliding into each other. So if we have value colon t. This is just going to be js.undefined, which is what functions return if they don't return anything. And okay. So now use effect will just be a function 0 to effect callback return for both of these. And my headphones are running out of battery apparently, so I'll probably just stop streaming anyway. It's almost an hour. So now we're gonna have use effect. There's gonna be something to an effect callback return, and then we can should be able to just directly pass this in actually. Yeah. Okay, this is much nicer. So here again, just effect callback return, and the nice thing is because this is already defined as like a proper function, then that matches the shape of the JS function we want. Scala.js will automatically convert it for us. Okay. So now let's check out what's going on here. Okay, it's still compiling that stuff for some reason. Okay, so that works at least, okay. And does this compile? Okay, that compiles, and does this compile? No, this does not compile. Okay. It does not like this. So what if we manually say this is a slinky.core.facade.effect callback return? It still doesn't like it. Okay. Cannot be applied to function to, oh, let me put this in parentheses. Interesting. So it's okay with that, but for some reason the implicit conversion is not happening. Let's see what could be a nice way to do this. How about this? Let's do some more type foo. So we're going to take a type parameter. This is going to be a function to t, and we want t to be convertible to an effect callback return. This is ugly, but I guess it works. Thunk colon, we're going to call conv on thunk. And okay, this is a little sketchy, but this might work. Okay, alternative cannot be applied to, okay, let's put this is nothing to promise. Okay, this is because you're using seek.props. So let's copy paste this chunk. So we're going to do this, but we'll have an additional parameter, and then we'll have the conv at the end, and we'll use this as our function. Where basically we wrap this original thunk in a converted version of that. And too many arguments. Okay, well, let's try compiling this again because I don't think it. Okay, it does not like this. Overloaded methods with alternatives. Okay, thunk to function to promise, and thunk function to promise cannot be applied to, oh wait, my parentheses are right, I think. Okay, thunk, which is something to t, okay. Let's try this without the sequence of props first. Okay, okay, because I'm going to do promise of assertion. Okay, so that compiles. Let's try it without this. Okay, it appears to work. Now let's see if it actually works and runs. Okay, this is a little sketchy, but hopefully this API works. Lots of implicit conversions are ideally the way it's set up. It shouldn't actually cause any problems later on. Ooh. Okay, unit tests are running. Oh no, error during test. That is bad. Okay, where was the error? Oh, wait, this is something else. Oh, wait, so did our actual test pass? Let's see, where is our hooks component? Where's hooks? Oh, let's search hooks. Oh, wait, I have duplicate test titles. Use for hook, unsubscribe function is called on unmount. Okay, let's try this. Hopefully this will work. All right. Hopefully because okay, all tests passed apparently, which is really cool. Let's check. See, where did we define this? If I call back from function from any. Okay, and let's double check. Okay, so we can also, of course, do this with, let's do this with complete, try, assert true, let's do assert false. So this should fail the test immediately. And that'll make sure that it's actually getting called. And we know that we're not having any problems with implicit conversions here because the other implicit conversion just directly just takes that value and does nothing with it. And so this should be fine. Okay, yes, that test failed. Okay, let's try without this. This is a little sketchy, but I want to see if it even has a chance of compiling without that implicit conversion. Because I get the feeling that what's happening is because it's just a function 0, there's actually no difference in the scala.js representation of it and the JavaScript representation of it. So we've actually always just been falling back to from any, is my hunch, and that will just work. Yes, no, okay, cool. Okay, so this wasn't the case. Okay, so this is necessary. Yeah, so what happened is the value just got called, so the function never got called. Okay, so the conversion is necessary, and we're not seeing any implicit issues with like multiple implicit conversions available, so that's a good sign. I think everything looks good. Cool, so we have use effect and use state working in Slinky. So I guess we finished the first 2 tasks. Probably maybe tomorrow I'll work on actually setting up an example project. I'm going for ideally a launch of Slinky 060 on sometime in the middle of this upcoming week. And so once hooks are done, there's the only remaining thing is the tags API, which I'm going to be working on rewriting, but this is a major chunk of it. So we're on track for the release. All right, cool. So that's working on Slinky. That was fun. I guess live streaming works, so maybe I'll try it again sometime. All right, let's see how I can shut this thing down now. Okay, cool. Bye, bye, bye.